All right, so I recently learned about Michaelson Morley, and this is fascinating because I somehow wound up studying and experimenting with numbers and things regarding quantum physics and quantum mechanics without ever having learned about Michaelson Morley and his impact on the acceptance of Einstein's theory of relativity. And in case you don't know, Michaelson Morley performed some experiments about the time of Einstein's work to find out if there was a medium in which light traveled. And when I learned about his, and he supposedly disproved that there's a medium in which light travels. And this is largely part of how Einstein's theory of relativity gained traction, is disproving a medium, supposedly, within which light traveled. However, I approached this entire problem of quantum physics without knowing that was a supposition in physics that had been hypothetically proven, and so I assumed there must be a medium in which light travels, which is kind of ironic because when you look at quantum field theory, it's just assuming the medium is a field. So I approached this problem from a different angle, and what's fascinating is when you take a slinky that is so small that each of these loops is as big around has a diameter of the Planck length, and they vibrate like crazy, and photons then would be really strong linear waves in this grid of slinkies, and everything else is tangles. This would have relativistic properties, and Michaelson Morley's experiments were not at nearly a large enough scale. You'd have to measure the difference of light speed within the gravity well of probably the sun as compared to outside the gravity well of the sun. How do you measure the speed of light across those scales? My argument is the gravitational lensing is the answer to that. Take that for what it's worth. I'd also like to point out that on the subject of Einstein's field equations, if all of reality is made up of a suitably small isometric grid of slinkies, then every single physical property from not just the way photons travel, but every single waveform and particle formation would be expressible as some kind of tensor field. Food for thought.